All right, 7.2, standard form of quadratic function. All right, standard form looks like this: ax squared plus bx plus c, where these are all numbers, but a can't be 0 because then it's not a quadratic because that disappears. So you just have a linear. All right, the leading coefficient a is the same as in vertex form. The vertex can be found this direction, negative b over 2a, and then you plug it back in to get that, and this will make more sense once we start working problems. In other words, to find the x value of the vertex, we use this part, which is this, and getting that answer, and then you plug it back into the equation or the quadratic function, and it gives you your y value. Okay, the c value is the y-intercept. This number here, whatever number that is going to be the y-intercept, because the y-intercept is when x is 0, what's y? Well, if you plug in 0 here, you get 0. If you plug in 0 here, you get 0. So you're just left with that. All right, so first thing we're going to do is it says find the max or min of the quadratic function. Anytime you see these words, that's the same thing as vertex. Okay? Now, what I'm going to do is I'm just going to go, I'll show you how to fill this out in just a second. Let's find the vertex first. So vertex is x equals negative b over 2a. Guys, that's the beginning or part of that quadratic function that we already know. The only difference in quadratic function is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, that's the part of the vertex. So that if you drew a blank, if you're drawing a blank, just hopefully that'll help. Okay? So, all right, so that's that part. So what I'm going to do, again, you have to put it in order. It doesn't really matter, but this is your A, this is your B, and this is your C. Even if it's out of order, C is always your constant, B is always the number that's with just the x, and A is always the one with the x squared. Even if these were mixed up, it'd be the exact same way. Okay, so let's find our x value. You're going to take a negative, or the opposite of negative b, which gives us a positive 16, over 2 times my a, which is 2. Don't use your calculator until you have to. Right now we don't have to. 2 times 2 is 4. Now we're going to get 4. Okay? Now, that would be, if I just asked for the vertex, that is our x value. Anytime we're given an x value, to find your y value, you plug it in. So we're going to, for the y, we're going to say, and remember, f of x and y are the exact same thing. So we're finding f of 4, meaning let's plug 4 in. We're going to say 2 times 4 squared minus 16 times 4 plus 28. And you can let your calculator do the work. Hopefully I have one here at my desk. Yeah, hopefully it's charged. Okay, it is. All right, so I'm going to use my store button. I'm going to say 4, store, and I'm going to hit my X right here. And hit enter. Now I'm just going to type in this 2x squared minus 16x plus 28. Oops, and you can't see it. You get negative 4. Okay. Now, if I just asked you for the vertex, that's what you would put. But the way that Alex is going to ask it is, does the function have a minimum or maximum? Well, first of all, this opens up, okay? It opens up because that's positive. So we have at 4, negative 4 somewhere down here. I don't know. It's just a sketch. Okay, it's going to look like that. because our parabola, oh, that's a bad looking parabola, but pretend like it's good, because our parabola opens up in, that is a low point, it has a minimum. Now, what is the minimum or maximum point? We just found that. 4, -4. Now, I could have done this before I did all that. I was thinking that those questions were there. Now, this is how Alex sometimes will ask it. If it says point or ordered pair, this is what you put. It says, where does the minimum or maximum value occur? This is y values. That's your y value. So, what is the function's minimum? No. This is asked differently than in my other class. Where does it occur is your x value. Where is at 4? What is the function's minimum or maximum value? It is -4. Okay, so that is your y value. Sorry, my other class, it asks it different. Okay, so that's your x value and your y value. All right, next problem. Graph the quadratic function written in standard form. Okay, identify the leading coefficient. The leading coefficient is the number in front of your x squared. That is a -1. That is going to tell you that this parabola opens down. Now, identify the vertex of the function. Well, we got to do this. -b over 2a. To find the x value, you're going to do -b over 2a. The more you write that, the easier it will become. So it's -2 over 2 times -1. So when I plug in my b, it becomes a -2. Now, do not use your calculator until you have to. And we won't have to use our calculator here. 2 times -1, you got to simplify that first. That gives us a +1. Okay, so that's our x value. To find our y value when we know x values, you plug it in. So we're now going to find f of 1. That means we take our formula, and wherever we see an x, we plug in 1. This is going to give us a +1, but because of that, it becomes a -1. Plus 2 is 1, plus 3 gives us 4. Now again, you can let your calculator do that work. Then you don't have to worry about making this mistake right here. So let's store let's store 1 under our x, and then let's plug this in. -x squared plus 2x plus 3. And you'll notice that it gives us 4. And that's what I ended up when I did it by hand. Okay? All right. The axis of symmetry is x equals 1. All right? Yes, you have to write it as x equals. That's the equation. Now, how do I know that? Well, this here, our vertex is 1, 4. So I go up, right 1, up 4. Okay? I know it's going to open down. I also know that there is an axis of symmetry that goes through that. It is a vertical line at x equals 1. Okay? And there, see how it hits 1? It's always going to be x equals that x value, the x value of your point. Now, is the vertex a minimum or maximum? Well, I already told you it's going to look like this. We could tell that. So that there is a high point, so it's a maximum. Graph the function on the coordinate plane. Now, I have a feeling what's going to happen is in ALEKS, you're going to have to do 2 points to the right and 2 points to the left of that vertex, okay? It's a bad line. So that vertex is 1, 4. So here's the 1. We'd have 0 and -1. Those are 2 points to the left. Now my x values to the right. This is 1. It'd be 2, 3. Okay, now we already have used our calculator like that. So I'm going to now store -1 store x. What my calculator is going to do is plug that in, and it's going to kick out 0. Then we're going to plug in 0 into here, but I don't need my calculator for that. That gives me 0, this gives me 0. I just am left with 3. That's the y-intercept. Now I'm going to plug in 2. And I think I'm going to get 3 maybe. I don't know. 2 store x. Bring the formula, the equation back up, and we get 3. And then 3 store x. It probably is going to give me 0 when I plug that in. And it gives me 0, and it should. And the reason they have you do it like this is because this axis of symmetry. If we graph this function -1, 0, it is right there. What that axis of symmetry says is if there's a point to the left 2 lines, there's going to be a point to the right. Guess what? That's 3, 0. Okay? That's what that axis of symmetry says. Right here, we have a point at 0, 3. I bet you my other point, I'm not looking at it. I bet you it's 2, 3. And it is right there. Now, remember, it's not a V, it's a curve. I'm going to have to turn it upside down. Okay, so we've graphed it. Write the following as points. Okay, we have 2 good points because remember, x-intercepts, that is when y is 0. Now again, you don't have to have them necessarily, but we have them. We have -1, 0, and we have 3, 0. But not all of them are nice clean points like that. But what you do if you had to solve, okay, which we could, you would set your y equal to 0, meaning you would plug 0 in for your y. So here is my formula. We didn't have to because we graphed it and it was nice clean points, okay? But we have 0 equals -x plus, -x squared, plus 2x plus 3. Okay? Now, what I'm going to do right here is I don't like that x squared being negative, so I'm going to divide everything I see by a -1. Okay? I'm going to divide everything over here by -1 and here. So now I get 0 equals, that's going to be a positive x squared. 2 divided by -1 gives us -2. The sign changes. 3 divided by -1 gives us -3. Now, if you're going to use quadratic formula, you could have used it from here. But I now can, you can factor it, but it's just not as easy. This one, for me anyway, we always try to get our x squared to be positives. Because again, it's going to be x times x. The only way to get 3 is 3 and -3. I'm sorry, 1 and -3, or -1 and 3. But I need my 3 to be negative because that's the only way. Outsides plus insides give me that. Positive 1x, -3x gives me that -2x. So set both of these equal to 0. Here I'm going to end up with 3. That's where I got that one. Here it's going to be -1, and that's it. Now we didn't have to do it that way because we could see those points on the graph. We already did that. Okay. Now the y-intercept. The y-intercept, that is when you set your x equal to 0. And we already did that up here. When I plug 0 in here, I get 0 plus 2 times 0 is 0, so I end up with 3. So it is 0, 3. Make sure that 3 is in the y position. So again, if you were doing this, you would have y equals or f of x. Either way, it's the exact same thing, and you're going to do negative 0 squared plus 2 times 0 plus 3. Now I won't do this work anymore because we're trying to shorten all this. It gets so long when you have to do all your work. All right, domain. We're not breaking any rules. The two rules we can't do is we can't divide by 0. We're not dividing here. The other thing is taking the square root of a negative number. Nah. So it's all real numbers. We use every single x value. These are quadratic functions. Domain of all quadratics are all real numbers. And it's negative infinity to infinity. Now, but for the range, that's different. We do not use all values of our y. We only go up that far. And there's no hole there, okay? Remember, if there's a hole, you have to use parentheses. So we use all our negative numbers, and we go up as high as 4, because that is our 0.14. So we have a y value, and that is a solid circle. It's not a hole, so it's a bracket. Okay. Right here, the leading coefficient of A, leading coefficient is 2. Up to find the vertex, we're going to say x equals negative b over 2a. So we have negative 20 over 2 times 2. Don't do that in your calculator. You don't need it yet. Negative 20 divided by 4. If you want at this point to use your calculator, fine. The reason I say that is people will put this in their calculator wrong and get the wrong answer because they wouldn't. You have to put parentheses around the whole bottom. So, okay, so you get negative 5. That's my x value. How do we get our y value? Plug it in. So you're going to take our function. You're going to say f of negative 5. So wherever you see your x, you're going to put in a negative 5. Okay, we'll just let our calculator do this because it'll be easier that way. Alright, so I'm going to say negative 5 store x, and I'm going to plug this in to x squared. You don't have to do it this way. I just do it this way because I don't have to worry about putting parentheses around my x and all that good stuff. And I get 112. Okay. Is that right? Did I do that correctly? I'm just double checking. That gives us negative 5, right? Gives us 112. Well, that graph's not very good because it only goes up to 10. But let me double. I don't know what I've done. It seems like this is wrong. I know I could factor out a 2, but I'm just going to double check because we can. This is okay. Because of this is positive, it's going to open up, and that means we have a minimum. Okay, the vertex is a minimum. So what I'm going to do is I think I taught you this already. So we're going to go to y equals. We're going to clear out what we have. Let's plug that in. 2x squared plus 20x plus 42. I know this is right because our y-intercept is 0, 42, so we can't really graph on this because that's a bad graph. Okay, so I'm going to go find my minimum. So I'm going to hit my second button, and I'm going to hit trace or calc, and I'm going to go to 3. Now we're not going to be, no, we do. I think I've done something wrong. Although, no, it's way up here at, no, I know this isn't right. Hold on just a second. Let me go back for just a minute. Oh, no wonder I didn't put an X in there. I was going to say, I didn't think it was going to be like that. Okay, it would help if you know how to type in the correct function. It's 42. That's right. Let me make sure my x is, oh, yeah, that's right. Isn't it? Okay, I don't know. I'm trying to talk to myself. Store x, then it's 2x squared plus 20x plus 42. Ah, there we go. I was going to say that would have been 0. Okay. Oh, sorry, guys. -5, -8. That sounds better. Okay, that's better. Now, if I went back here, okay, and then of course, I went second calc, and it's a minimum because I know it looks like this. I'm going to go to 3. All right, I have to put my cursor on my left bound. It comes up on the y-axis, so we can go ahead and put 0, 42. I mean, that's our y-intercept. If I plugged in 0 here, I'd get 0. 0 here, I'd get 0. So that whole thing gives me 0, so I'm left with 42. Okay, so I need to use my left arrow key, bring my cursor down. It needs to be on the right-hand side. It's right there. I'm just going to hit enter. It can be anywhere there. I'm going to go to the left-hand side. I'm sorry, that was the left-hand side. This is the right-hand side. And see how my vertex is between these two really light lines. Sorry, it's hard with my light up above. And then I'm going to hit enter for a guess. And it says -5, -8, and that's what we got. Okay, so let's graph that. I'm going to count left 5. 1, 2, 3, 4, 5, down 8. 1, 2, 3, 4, 5, 6, 7, 8. Put a point. That's my vertex, okay? And that is the point, -5, -8. Well, we have an axis of symmetry that goes through the middle of that. Okay, and that is an equation of a line. In order to do a vertical line, it's x equals some constant. That constant is going to be -5. Okay, graph the function. Now, guys, because of that, I really don't have to do a lot of work on my calculator. I only have to do 2 more points, but I'll show you all of them. Okay, so we have, it's going to make you, Alex is going to, let's put this in the middle, -5, -8. Well, the 2 points to the left is -6, -7. Okay, that's 2 points to the left. And then 2 points to the right is -4 and -3. But you only have to do 2 of these, and that's because of that axis of symmetry. Now, and actually, what you're going to do, if you were doing this all by hand, okay, you would take the -7 and you'd plug it in here. Okay, so you're going to do -7 store x, and you get, then we're going to plug in 2x squared plus 20x plus 42. Make sure your function is correct, because it'll give you the wrong number, like as you already know from up here. And we get 0. -7, 0. That is, go over to -7. This is 1, 2, 3, 4, 5, 6, 7, right there. Guys, because of that axis of symmetry, I know there's one right here too, at -3. Okay, that's a bad point. So I guarantee you, when I plug in -3, it's going to come out to be 0. And then -6, store x, bring the other one back up, and you get -6. Guarantee you, this one's going to be -6 as well, because of that axis of symmetry. You're going to go left to -6, down to 4. 1, 2, 3, 4, down to -4. If there is a point to the right of of that axis symmetry, I'm sorry, to the left, there's 1 to the right. Now, I'm going to prove it. -4 store x. For -4, I get -6, and then for -3, store x. Bring it back up, and I get 0. See, so you really can cut down on some of this work. Now remember, take it slow. This one's going to be kind of hard for it not to look like a V, but try the best you can. Okay. Now we have x-intercepts. Oh, this one's a nice one. It's right here. There's no sense in doing anything. But what you would do is you can factor it, because later on you're going to have to be able to do it without a calculator, without graphing it kinda, because sometimes they don't factor really well, and these are easy to see. So those x-intercepts are -7, 0 and -3, 0. And in ALEKS it'll tell you to separate it with a comma. Now, if you were having to do that by hand, you would, for the x-intercepts, it's always the same. Plug in 0 for y and factor, or use quadratic formula. I don't care what, if it asks for an x-intercept, no matter what your polynomial looks like, you're going to plug 0 in for y. Okay, so you're going to have 0 equals, I'm going to factor out a 2. And I get x squared plus 10x plus 21. Now 0 equals 2, and then this factors as x plus 7, x plus 3. Right here you get -7. Right here you get -3. You don't worry about the 2 because it doesn't have an x with it. You could have divided by 2 and it would be gone anyway, because 0 divided by 2 is 0. Okay, and then this one, to find that out, you make x equal to 0. So it would be 2 times 0 squared plus 20 times 0 plus 42. 0, 0, we get 42. Okay, domain. Domain of all quadratics, -infinity to infinity. Okay. The range, however, we don't use all the range, all the numbers. Our smallest number that we use right here is -8. Okay, that point is down there at -8 on the y-axis. Okay, so that is our smallest number. There is no hole, so it's a bracket. But it does go on forever, so it's to infinity. Okay. Oh, and by the way, on these type problems, the ones they've given us, it was nice even numbers. If it's not, then you have to use quadratic formula because it wouldn't factor. Okay. Oh, I forgot to show you. If you're going to use your calculator, okay, you can go to your table, hit second graph, and here's a whole lot of points. We just graphed these points. There's -3, 0. There's -4, -6, -5, 8. There's -6, -6, and -7, 0. Okay. All right. Now we're going to take something from standard form, changing standard form to vertex form. And they have 4 methods. I don't know what the 4 method is, but I'll go with it. Okay. Use complete, oh, because we have to complete the square to write that in vertex form. Nope, I'm not doing I'm not doing that, okay? I think what they're doing is just trying to get you to revisit completing the square, so I'm not doing that. There's no reason for it. If you find some in your homework, I don't think it'll do that. I don't know. I'll have to look at that. But here's what I'm going to tell you to do, because it's already a weird thing to do for vertex form. Vertex form looks like this. And we talked about this in 7.1. It is A, then you have x minus h, that's your x value of your vertex, squared, plus k. Okay? Now, the nice thing about standard and vertex form are our a's are the same. Okay? So right now, we can plug our a, we know our a is 2. Okay? We have to find our h and our k, and then we have vertex form. Because h and k are our vertex. Well, we just learned how to find the vertex. I don't care what the directions say. I would never do it that way. So let's do negative b over 2a. So we're going to say negative 20 over 2 times 2. Do not use your calculator yet. Negative 20 divided by 4. If you have to use your calculator at this point, that's fine. And you get negative 5. Okay? That is this right here. That's your x value of your vertex. Now, the correct way of writing that, because it's minus a negative, would be x plus 5. And don't forget about your square. I told you in class I sometimes forget that. So now to find your y, you're just going to plug this in. You're going to say 2 times negative 5 squared plus 20 times negative 5 minus 5. And I believe we've already done this, but because I think there's another problem on the other page. Okay, so you're going to say, well, let's do negative 5 store x, okay? Or you can type it in just like that. But I would do it this way and go 2x squared plus 20x minus 5. And we get negative 55. No, I don't think we did that. Okay? So, our y value is negative 55. So, it would be plus a negative 55. That seems really big, but... So that is, instead of writing it like this, plus a minus, we're just going to, or plus a negative, we're going to do minus. 25, 50 minus. Okay. All right. Now, we just wrote our new function. Now, you can check it because we have graphing calculators. Now, if you're at UT, depends on your instructor. Some of them allow graphing calculators, some don't. So here's what I'm going to do. I'm going to go into my y equals, and I'm going to put this. And all I have to do is change this. Minus 5, and I can delete that. Okay? Well, these two are the same quadratic form. Let's try this again. They are the same parabola, the same quadratic. So they will look the same. So it's just written differently. One's standard form, one's vertex form. So what I'm going to do is under y2, I'm going to put our vertex form. If this is correct, it will lay on top of that. Now in mine's a color calculator, so you're going to see the blue, and I don't know if you'll be able to see the red, but we'll see. Oh, it's a funky one too. See how we really are zoom. Oh no, it's wrong because it doesn't lay on top of it. I've done something wrong. See, I need to do this in class. Okay, let's try this. Negative b over 2a. So negative 20 over 2 times 2, which is 4, which is negative 5. When I plug it in, I get 2. Oh, did I do it right? Oh. If I could use my calculator right, I still have a 2 there. It should be minus 5, not 52. I was going to say, all my work was right. Okay. So now let's try this again. Let's try graphing it. It's still not in the right zoom because you can barely see it, but you can see part of it. Here comes, it's going to turn into red. See, I don't have to do it so that I can see it, because I know the part that I can see. One time it was blue. I don't know if you can tell, but when I'm looking at it, it was blue. Now it's red because the red one's, this one was red. So if I wanted to, I could hit zoom 8, enter, and I think you'll be able to see it. Yeah, you can see that more. See how it changed colors? It went from dark to light. So I know it's right. Now that I know how to typing it in correctly. Okay, same thing, having you practice that. I'm not going to have you do completing the square. Okay, you can get through this, through your math career without knowing how to do that. So, all right, vertex form. Now, by the way, remember, now you have to know that's the form, that's vertex form. The A is the same in vertex form as it is in the original standard form. So our A is -3 in our standard form. It's -3 in vertex form as well. So it's x minus whatever my x value of my vertex squared plus my k, which is my y value. So let's find the vertex. -48, because it's negative b, over 2 times my a, which is -3. This gives you -48 over -6. That gives us a +8. Now plug that back in. You're going to say -3 times 8 squared plus 48 times 8 minus 165. Okay, so I'm going to say well, I don't know why I'm doing it this way, but oh well, I've already started. Plus 48 times 8 minus 165, and I get 27. Okay, so this is my vertex of 8, 27. So what I'm going to do is, that's 8, and because that's a positive 27, it's plus 27. And I just wrote it in vertex form. You know, if I multiplied all this out, if I simplified this, it would look like this. Okay? We just don't. So I don't think I can check it because I think that's going to be a negative. I don't know that it'll show up because of the way it looks. I'll try it, but I don't think it will. But it might, part of it might show up. -3x squared plus 48x minus 165. I'm going to make sure it's typed in right. Obviously, I'm having trouble with that. Then down here, I have -3 parenthesis x minus 8 squared plus 27. And I don't know, mine's in zoom 8 still. I'm just going to leave it. Well, let me put zoom 6. Zoom 6. I don't know if you'll be able to see any of it. Well, there's that one. The other one will make it change color if it's right. And see, it just made, again, I don't know if you could see that, but it went from blue to red. I'll do it zoom 8, enter. You'll be able to see a little bit more. There's the blue one, and there's the red one. Sorry for the noise. I'm trying to cover up my mic. My husband's out mowing the lawn, and now he is blowing all the grass off. So anyway, and he's right outside the window. Okay. Using the formula to find the vertex, use the algebraic method. That's the whole thing. I just did this. Okay. That is that problem right there. Okay. That's that problem there. So I'm not going to do that one again. Now, using the calculator to find the vertex. This is not the algebraic method. Well,